Hi folks, so today we'll be talking about a tool called Shellter. I want to present a demo on how to use the tool and what you can do with it. But before we get to the demo, let's check out what it is and how it works and what use it has for your pen test scenarios. So the Shellter website defines it as a dynamic shellcode injection tool. And basically what that means is that you can take a piece of shellcode or a payload and you can inject it into a pre-built executable. So let's say you have a Microsoft Windows binary. So you have a .exe file and you want to inject a payload into it. Shellter allows you to do that. I have seen in multiple places where Shellter is mentioned as an AV bypass tool as well. So it allows you to build executables that can bypass AVs. I'm not 100% comfortable with that definition. It does allow you to do that, but I think it allows you to do that by hiding the malware within another executable. So I don't want to say it focuses primarily on antivirus bypass, but yes, that is a a byproduct of what it does. And I think it says that somewhere here. It says, yeah, the executable won't look dodgy under an AV scanner if you've embedded it into another executable. Right now, Shellter only works on 32-bit applications, so you can only inject a 32-bit application with a payload and not 64-bit. It, however, does work on both. You can download and install Shellter on both your 32-bit and your 64-bit system. So moving on to the downloading, you can download Shellter from this URL, shelterproject.com/download. It's compatible with Windows and Linux or Mac. I primarily use Linux, so I've been working with it on Linux, and the Wine crossover works perfectly for me. I've never faced any issues. I haven't done very complicated things with it, so maybe that's why I haven't run into issues. But regardless, it works great on Linux as well. That's what the website has to say about it. You can also check out the Kali page for the same Shellter. I think they might give some more information on it. You'll have to check this out. I haven't taken a very good look at it, but just looking at these links here, Kali Shellter repo, it seems like Kali also provides Shellter within the Kali operating system. And having said that, Kali is a Linux-based system, so I'm assuming a lot of the Linux bugs have been ironed out. Just because Shellter's association with Kali, I'm sure they must have worked together on that. Having said that, let's move on to the demo now, and we'll see how we can use Shellter, and then as we go, I'll keep describing scenarios as and when they come. So like I said, I'm on Linux and I've been using Wine for Shellter. So the first thing I'm going to do is just start Shellter and take it from there. Okay, so it asks us for an operation mode. I haven't worked with manual mode much, and I'm not sure what the H does. I have never used it. Perhaps after this tutorial, I'll take a look at manual and the H as well and what it stands for. For now, let's just choose automatic and see where we go. So PE target. The PE target is the executable that we'd like to target. In this case, I've gone ahead and I've downloaded Putty. Putty is a Windows executable which allows you to SSH into another machine. So it's completely unrelated to our payload. It has nothing to do with Shellter. It's a completely different executable. So I've downloaded it ahead of time and I have it in one of my folders, and we'll use that as the initial PE target. While I'm at this page, I'll also tell you the second target that I've chosen for today. So we'll be doing it on two separate executables. Stellarium. For those of you who are astronomy enthusiasts, you probably already know about Stellarium. My personal recommendation would be, you can install this. It's a really cool tool. But for the purposes, I've downloaded a Windows 32 executable, and we'll try to inject this with a payload as well. So let's move on back to the demo. So since putty is our is our first executable that we would like to inject, I will put that there and let's see how that goes. So it makes a copy, a backup of the file. However, it didn't make that for me because I've already backed it up multiple times before. This step does take a while. So what I'm going to do is I'm going to pause the video here and we'll come back to this. Yeah, it should be about completing soon. It usually takes about 45 seconds on my machine. We're close to that time now. This basically the DIS ASM, the .dll, that's basically the file that it uses to inject into our executable. So that's what it was able to successfully create here. And creating that, just setting that up takes some time because it traces instructions, it tries to figure out where exactly in the exe to inject that payload. So now that that's done, it's asking us whether we want to enable stealth mode, and 100% we want to enable stealth mode. That's what we're trying to do. That's why we're using Shellter, mainly to do some antivirus bypass if we can. So now once we do that, it'll give us a list of payloads that we can use. Most of them seem to be Meterpreter payloads. I wouldn't be surprised if behind the scenes these last three are also coming from something like MSF Venom, precompiled MSF Venom binaries. Regardless of that, you can go ahead and choose any one of these from the list. And when I say list, that's what you can specify here. So it's asking you whether you'd like to use a listed payload or you'd like to use a custom payload. And again, the H, I am not sure what it means. I have not worked with it before. So I'm going to go ahead and use a custom payload. I prefer a custom payload because it allows me a lot more flexibility in terms of, let's say what encoder I want to use, how many times I would like to encode it, what payload do I want to use. I mean, maybe I want to use a payload that's outside of these 7 mentioned here. So I usually like to use a custom payload, so we'll go ahead and do that. So let's create the payload first. And I've got my MSF Venom ready to run here. I'm going to be creating a payload. I'm going to be using a payload for the Windows. It's going to be a Meterpreter, and it's going to use a reverse TCP for connection. The local host I'm using as my local IP address, which is 192.168.0.181. The port number 4444. For the encoding, I'm using Shikata Ganai. There are multiple encoders that you can use within MSF Venom as provided by the Metasploit framework. Shikata Ganai just seems to pop up everywhere. It is really good, and I've used it multiple times, and it always it works well. So I've decided to use that. The -I is a number of iterations of encoding that you'd like. So I'd like to encode my payload once, twice, thrice, up to 10 times. So I want to encode it 10 times and then basically just give it the location of where it wants to store it. One other option, the -f raw. That means the format that I want the payload to be in is raw. Raw format means I don't want it as an exe, I don't want it as a Python script. I want it as binary. And the reason we choose binary is because it's much more easier to inject into another executable. So let's run that. It shouldn't take long. Oops. Okay. Perfect. So we have that run. That's completed successfully. It tells us 624 bytes, fairly small size. So let's set this payload on our Shellter terminal, and let's see where that goes. So is this payload a reflective DLL loader? So reflective DLLs are basically DLLs which will run in memory. Because we're not loading any DLLs into memory using this payload, this is not going to be a reflective DLL loader. So we'll just go ahead and say no. And I think that should be it from Shellter's side. It just runs, press enter to continue, and I think that'll exit. It did. So perfect. So now we have our putty.exe, which has been injected with our payload from here. So let's test that. How do we know that this putty has been injected with this payload? So what we'll do in order to test that is, let's first go and take a look at what we had specified in the payload very quickly. I know we've done it before, but we'll still go over it. So we specified the IP address as .181 and the L port as 4444. Next, what I'm going to do is I'm going to start a listener, a simple netcat listener on our port 4444, and then we'll run putty and see if we get a connection. So that's running. Going back to my wine and just type putty again, because putty is a Windows executable. I need to run it using wine, and let's see what happens. So putty pops up, which is really good because if you give someone this executable and they run it, putty works as normal, right? So they have no idea that there's some sort of a background connection taking place. And here, if you notice, we've got a connection, right? The reason we don't have a interpreter shell here is because our netcat is not capable enough. Well, that command on netcat is not capable enough to handle a interpreter session. But if we had, let's say, a more complex multi-handler that could handle this connection, we would see a interpreter shell. So that's perfect. That's exactly what we wanted. The next step that I'd like to present is we want to see what VirusTotal can find within this putty.exe. So we'll run it through a check and see if VirusTotal can detect, if there's a malware in here or not. So putty is fairly small. It's like 1 MB, something around that size. So this should be fairly quick. Later, when we try a much larger, a larger file that we inject, this is going to take a lot more time. So that seems to be taking some time. So let's pause it here and I'll come back to it when it's completed. Perfect. So we can see that 40 out of 70 engines detected it as a Trojan. There was one very interesting one. There it is, Fortinet, which actually told us that it's a Shellter. You're using a tool called Shellter to create this. So that's pretty interesting. Sophos detects it. Sophos is pretty much what I use on Ubuntu. And that, deletes my file every single time. But however, there are a few good ones. I know Silence is a good one, and that doesn't detect it. Komodo is fairly good. That doesn't detect it. I am surprised that Palo Alto Networks, Trend Micro, also don't detect it. But there are a few big names as well that don't detect it. Semantics one, Trend Micro is another. CrowdStrike's another one. So that you can use this to get by, but majority of the times I think this will get caught. It is a fairly simple, and I think the size factors in there because it is so small. It's easier to scan it. It's easier to just detect that it is malicious. So let's try another experiment. Let's try it with a much larger file. So we'll go through the same process, exactly the same, maybe a few variations, but pretty much the same thing, and we'll see how this pans out in that case. So let's go back. I'm going to close this putty, and that should kill our session. Perfect, kills the session there. And let's retry the same command, the same Shellter, but this time we'll choose the Stellarium payload, the exe. So again, I want to choose automatic, PE target. I am going to mention Stellarium. Okay. Now this will take some time perhaps because it is larger. Okay, awesome. So it tells us not to use packed executables. It's more of a warning. We'll still try it. It has worked for me before. I've done tests on this before I created the demo. So we'll go ahead with this. Primarily, I just want to test the size in this case. We're back to that page where I'm going to pause because this takes around 45 seconds and we'll come back to this in a bit. Okay, so it should be done soon. In fact, it mentions it here that it will take 60 seconds, approximately 60 seconds if you use Wine. I timed it at 45, 46 seconds. So this should be done soon. Perfect. That's done. Enable stealth mode, of course. Again, I'm going to go with the custom payload, so the C. Now let me go back to our payload section. I want to generate a new one. And the reason I want to generate a new one is because this time I want to give it more iterations. So I want to maybe iterate it, let's say 25 times. So I want to encode it 25 times. Let's run that. Perfect. So now that that's complete, I am going to take this payload again, paste it back into my Shellter window, and let it roll from there. Again, not a reflective DLL. Perfect. Okay, so I think we're done here. Next, let's run the same test as we did with the netcat listener. So I'll run it on the same port. We didn't make any changes to the IP or the port, so that information is the same. And then here, I'm going to run the Stellarium again via Wine. Awesome. So it did actually work. So that's perfect. Now you may notice that there is a small difference in the payload size. So you've got 43060, 43276. So this one's slightly larger than the first one. The reason is that the connection coming back to our netcat is coming from the meterpreter that we added up here. It is a meterpreter shell. And the size difference, I believe, is because the first time we encoded it only 10 times, hence this is smaller. The second time we encoded it 25 times, and hence this is larger. Either way, our exploit was successful, and that's good news. So what we'll do next is we will go ahead and upload this malware that we've generated using the Stellarium executable on VirusTotal and see how that pans out. So I'm just going to duplicate a tab. I'm going to look at the results later. And here I am going to just drag and drop this new Stellarium executable. So one thing I do want to mention here is all of these executables are overwritten. So Shellter will typically overwrite them. So that's why I usually have a backup copy here that I can use just to copy paste quickly and in case I want to generate new. So just something to keep in mind when you're playing around so that you're not hunting around for, oh, where did my executable go? Now this is going to take a while because it is 251 MB. So I'm going to pause the video again and then we'll come back to it. Okay, so the uploading finished and now it's basically just analyzing it. I will say I'm really happy with what I'm seeing so far. Doesn't seem to be very recognized. I think Bitdefender and McAfee are doing a great job. But yeah, so this is really nice. This is so much better than, if you contrast it with what we had earlier, 40 out of 70. We've already reached 59 and we're up at 11. So I'm really optimistic about this one. And we can see who all were not able to detect it. So again, big names, Palo Alto Networks, I've heard of Tachyon, Trend Micro, definitely. There were Komodo is another one. So really cool results. I would say, a lot of good companies were not able to detect it. So that's our percentage of success. I mean, 13 over 63. If you were to do this in a a real world scenario, a lot of the major antivirus vendors are not detecting it, which is a good thing for a pen tester. You'll get better results if you do use a larger executable. The downside may be you'll have to upload it. It takes long to upload. Larger uploads mean they might be able to detect it. If they're looking at things like the sizes of files that you upload and so on. Either way, I mean, that's something to think about. And I personally believe that it's because of the complexity of code. The more complex the code that you're trying to inject in, the harder time an antivirus and an EDR tool will have to detect an embedded malware. And I think that's an amazing result. So let's go back to our screen. There's one last thing that I wanted to mention here. So we see that, using automated tools such as Shellter, Metasploit or MSF Venom are really cool. They are giving us very good results, but it's not always 100%, because if you've used MSF Venom, chances are that someone's already worked with MSF Venom and they already have the hashes for that with antivirus or EDR providers. The best way I would believe that you can get successful antivirus evasion, maybe even 100%, is if you are writing your own shellcode. And when I say writing your own shellcode, essentially what I'm saying is if you're writing your own assembly level code, that's primarily what a lot of exploit developers do. Very experienced exploit developers will write their own shellcode, whether they generate it through one method or the other. And just having to talk about shellcode, I'll also present what it looks like, what it would be like to see a segment of shellcode, and we've already got it here. So this is our shellcode, and we can take a look at it. If we try to render it in the command prompt, it will come off as complete garbage. It's just some garbled nonsense that is not human readable. However, if you were to do a hex dump on it, which is, represented in the hex format, in that case, you will be able to see a lot more structure. So now you can see a lot more structure, and you can see each one of these is actually a command for the operating system. In fact, it goes even lower. It goes down to the assembly level. And that is how you can manipulate memory level instructions to make sure that the malware does whatever you want it to. So I think that's mostly what I wanted to cover. I'm not sure if I mentioned, I did try this on the Steam installer as well, but that didn't work, and I presume it's because of the 64-bit. But other than that, I really hope this this demo helps, and it helped you learn something today. If you do have any questions, please don't hesitate to reach out. I would love to get some comments, or if you want any doubts clarified, you can always reach me. I'm not sure how you will be getting this video. I will be sharing it on my blog, on YouTube, and certain other Slack channels. So either way, wherever you get it, please don't hesitate to reach out. If you have any questions, I'll be more than happy to help. And thank you. Bye-bye.